Hello, this is the second part of the chapter 5.2, and we will talk about characteristic equation. In the previous chapter, we discovered that the value of lambda can be found from the equation, which we call now a characteristic equation, which just our matrix with value of lambda subtracted from the left diagonal element, and the determinant of this matrix is set to 0. And this characteristic equation is essential for helping us to find all the eigenvalues for our matrix. And last time we looked at the 2x2 matrices, and determinant was pretty easy to find. Today, let's just look at the larger matrix. Let's look at this 4x4 matrix, and let's find the characteristic equation of this matrix and all the eigenvalues of this matrix. And again, we will start writing down characteristic equation by finding the determinant of the matrix A minus lambda times identity matrix, which is, again, we just take a left diagonal of our matrix and subtract parameter lambda from all these diagonal elements. And because we were really lucky here, we have a triangular matrix, which is a joy to find the determinant, because determinant of triangular matrix is just the product of its diagonal elements. So we can multiply all these diagonal elements, and that's the determinant. And our characteristic equation is taking this determinant and setting up it equals 0. And that's an example of characteristic equation. Again, we have a 5 minus lambda here listed 2 times, so I raise it to the power 2. Sometimes it can be useful to actually write it down in terms of the polynomial instead of the product of differences. And in this case, it's called a characteristic polynomial. But I personally prefer the characteristic equation in the difference form because it helps us to find the zeros of the polynomial really easy. For example, this first term will give us a value of lambda is equal 5. And because it's raised to the power 2, or because 5 minus lambda was listed twice in our diagonal elements, it has a multiplicity equal to. There is 2 other values of lambda from the second and third terms. Second terms gives our 0, lambda equal 3. The third one gives a lambda equal 1. And because the power of both of them is 1, they have a multiplicity of 1. And that's how you can find the characteristic equations of the triangular matrix. Those are really pleasant to work with. Every time you can reduce your matrix to a triangular form, your characteristic equation and finding the eigenvalues are very nice and easy.